Now see here, why 9 is equal to 0? Suppose for example, I take a number called as 32. 32, what is the digital sum? Digital sum of 32 is 5, right? 3 plus 2 is 5. I will take the same number 32. I will divide it by 9 and I will find the remainder. Remainder when 32 is divided by 9. What is the remainder? 9 into 3 is 27. Remainder is how much? 5. Can I say that these both are same, right? These both are absolutely same. Both the ways you are getting same 5 as the answer. Suppose another example, you have a number, for example 43. 43 digital sum is 4 plus 3 7. Same 43 I will take, divide it by 9, find the remainder. Remainder when 43 divided by 9. 9 into 4 is 36, remainder is another 7. These both are absolutely same. That means, can I say that you take any number n, divide that number by 9, find the remainder. Whatever the remainder that you are getting when you divide that number by 9, that remainder is exactly same as digital sum of that number, right? The remainder is exactly same as digital sum of that number. That means remainder when a number is divided by 9 is exactly equal to digital sum of that number n, right? Digital sum of that number n. Now listen carefully, sir. Digital sum of that number n, we made a conclusion already, but now let us take a number called as 36. 36 digital sum is how much? 3 plus 6 9. I will take the same number 36, divide it by 9, find the remainder. Remainder when 36 is divided by 9, 9 into 4 is 36. What is the remainder? Nothing is left out there. Remaining is 0. These both are same. 9 and 0 both are same in digital sum. You asked me a question, what if it is the digital sum of 9999? If you are using a concept called as digital sum, 9 plus 9 18, 18 plus 9 27, 27 plus 9 is 36. 36 digital sum is 3 plus 9. 3 plus 6 9. If you are asking, or if you are using a concept called as digital sum, it is 9. If you are using a concept called as digital root, if it is 0, we will call it as digital root. That is the only difference. Delete all the 9s. All 9s are deleted. You will get it as 0. Anyway, 9 and 0 both are same in digital sum. It can be interchanged. Right? It can be interchanged. Like, I hope the idea is clear, sir. Now, this is the concept what we learnt. Now, see here, sir. I am damn sure that you all know the multiplication of 9. 9 tables, I am damn sure you know it. 9 into 1 9, 9 into 2 18, 9 into 3 27, 9 into 4 36. Like that the table keeps continuing. I am sure that you know 9 tables, but I am not sure whether you know what is the usefulness of this 9 table. How beautifully you can apply digital sum in 9 tables. 9 digital sum is 9 itself. 18 digital sum is also 9. 27 digital sum is also 9. 36 digital sum is also 9. 45 next number digital sum is also 9. Can I say that you take a number called as 9, you multiply this 9 with any number of your choice, multiply 9 with any number whatever you like, digital sum will always be equal to 9. 9 is multiplied with any number, digital sum is always 9. Suppose I take multiple of 9 18. 18 into 1 18, 18 into 2 36, next it is 54, next it is 72, it is 9 again, 36 is 9, 54 is 9, 72 is 9. Any multiple of 9 multiplied by any number, it is not only 9 multiplied by any number, the rule is for multiple of 9 multiplied by any number, digital sum is always 9. I believe the idea is clear. Multiple of 9 multiplied by any number, digital sum should always be 9, right? It should always be 9. Now you might ask me a question, Sir, this is one of the technique which you discussed right now. This is one of the technique which you discussed. This is one of the statement you told us just now. There is another statement you told 5 minutes before, that you can delete 9 in digital sum, right? You can delete 9 in digital sum. You made two statements as of now, but I want to understand where can I use these two statements. I am more interested in application part of it, sir. I want to know where can I use this in my question, so that my problem solving will be effective. Now listen carefully, sir. A beautiful question which came in one of the competitive examination. I am putting the exact question on the board for you, right? The question is, it was given in an English statement. I am converting it to a mathematical statement. Question is, 3 into 230 plus x whole square. 3 into 240 plus x. This was the question which came. 3 into 240 plus x whole square. This is equal to 54908a. 3 into 240 plus x whole square is 54908a. You need to find the variable a value. What is the value of this variable a, right? 3 into 240 plus x whole square is 54908a. What is a value is the question. Now listen carefully, sir. Very, very beautifully you can solve. How students will solve? First of all, let us understand how students will solve this question. Students will solve like this. They will think that 3 square is nothing but 9. 3 square is 9. 240 plus x whole square, they will write it as it is, right? They will write it as it is. Right hand side is 540 plus x whole square is nothing but a plus b whole square. You will apply a formula called as a square plus 2ab plus b square. When you apply that formula called as a square plus 2ab plus b square, when you expand it, you will get b is nothing but x here. B square is nothing but x square. X square is a quadratic equation. You will again apply one more formula saying that x is equal to minus b plus or minus square root of b square minus 4ac by 2a. By the time you complete this question using those two formulas, your friend who is sitting next to you, he or she will complete 4 to 5 extra questions, because he or she is good in conceptual learning, but probably you are good in formula based learning. This is where you need to change the way you look at things and solve an aptitude questions in the way it has to be solved, like the way we solve in Anil Nair classes YouTube channel. Now see here, sir, we are not interested in using all those formulas and wasting our time. Just 2 minutes before I discussed this concept, 9 multiplied with any number, what should be the digital sum? 9 multiplied by any number, digital sum is always 9. That means left hand side digital sum is 9. Left hand side digital sum is 9. If the left hand side digital sum is 9, right hand side digital sum should also be 9. Can I say that in digital sum you can delete 9? I am deleting this 9. 5 plus 4 is also 9. I am deleting this 9. Right hand side digital sum should also be 9. 8 plus a. 8 plus a should give me digital sum as 9. What should be a value? A value is 1. How beautifully you can solve this problem, sir. There is no need for you to simplify this question by using a formula based approach. You can actually as well simplify this so beautifully by using a logical based approach, which we learnt 5 minutes before. In digital sum, 9 can be deleted, and 9 multiplied by any number, digital sum will always be 9, right? It will always be 9. This was one of the question which came in one of the competitive examination. Original question which came in the examination, I drafted it in terms of what do you say, like mathematical expression. Instead of English statement, I gave it in a mathematical expression. Now after this question came in one of the mock examination, they gave this particular question. I am writing the similar kind of question, only the numbers are different. 3 into 230 plus x whole square, just for your understanding. 3 into 230 plus x whole square is 4928, sorry, 49a, it is not 2, it is 49a804. 49a804, a value you need to find. Now you know how beautifully you can solve this question in seconds. Very, very easy. 3 square is nothing but 9. 9 multiplied by any number, Digital sum is 9. Right hand side also it should be 9. Delete 9. 4 plus 8 is 12. 12 plus 4 is 16. 16 digital sum is how much? 1 plus 6, 7. 7 plus A. 7 plus A should give me digital sum as 9. A value should be 2. You can solve these varieties of questions so beautifully, so easily by using this methodology of digital sum. Kindly avoid using formula whenever it is not required, wherever it is not required. I believe the concept is very, very clear for you, sir. 9 multiplied by any number, digital sum is always 9. And the second thing is, in digital sum you can delete 9. Wherever I get sum of 2 or 3 terms giving me as 9, I will keep deleting, or wherever I get 9 itself as the one of the digit in that number, I will delete it directly. I hope it is clear, sir. Idea clear, sir. Next, another question before we move on to our actual topic on simplification. Your question is square root of 20 into 21 into 22 into 23 plus 1. Square root of 20 into 21 into 22 into 23 plus 1. Options are 441, 451, 461, 471. Square root of 20 into 21 into 22 into 23 plus 1. Options are 441, 451, 461, 471. Now, whenever you have square root, to apply digital sum, suppose for example square root of 9 is 3. Square root of 9 is 3. What I will do is, I will remove the square root and put square on the other side. 9 will be equal to 3 square. Same thing I will do here. I will remove the square root. I will put square on each and every option. Right? I will put square on each and every option. Now there is no square root in my question. I will apply digital sum. 20 digital sum is 2. 21 digital sum is 3. 22 is 4. 23 is 5 plus 1. 5 into 4 is 20. 20 into 3 is 60. 60 into 2 is 120. 120 plus 1 is 121. 121 digital sum is 1 plus 2, 3. 3 plus 1, 4. Question digital sum is 4. Answer also it should be 4. 4 plus 6 is 10. 10 plus 1 is 11. 11 digital sum is 2. 2 square is 4. Question digital sum is matching with answer digital sum. This should be the correct answer. Whenever I have the square root, apply square on answer options. If the question is having only square root, not plus something extra, right? So please don't get confused, right? Apply square on all the answer options so that you will get the answers very, very fast. I hope the idea is clear, sir. Now, suppose for example, if the question is the division, 294 divided by 6. I am just taking an easy question for you to make you realize. Options are 29, 39, 49, 59. Now, whenever, suppose for example, if I directly apply digital sum, 9 is cancelled. 2 plus 4 is 6. 6 divided by 6 I will get, and I will get it as 1. There is no option which is having digital sum 1, but one of the option is definitely correct out of these 4 options. So whenever it is division, you cannot directly divide like that and get the answer. That is the wrong way of problem solving. When you have division, convert it to multiplication. 294 divided by 6, I will assume it as first option, for example 29. So now I will convert it to multiplication. 294 is equal to 29 into 6. Here the digital sum is 6. Here the digital sum is 3. Not matching, ruled out. Not matching, ruled out. Fourth option will not match, ruled out. Third option should be correct. When you have division in your question, to apply digital sum, if at all you need to apply digital sum, I am telling you, sir, digital sum is not the only method to be used to solve our problems. This is one of the method, right? This is one of the method. Whenever we have digital sum, whenever we have division, if you want to apply digital sum, convert it to multiplication by cross multiplying, and then apply digital sum. Do not apply digital sum directly if the question is in terms of division, right? Now this is one thing which you need to know. Another thing that you need to know is, suppose for example I have a number, suppose for example I have a number 2.3, right? I have a number 2.3. Now 2.3 I will approximately write it as 2, right? For example 2.3 I will approximately write it as 2. That means 2.3 digital sum is, if there is a decimal point. There is one student who asked that doubt, Sudhir Kumar, what if decimal number is used? Your question, your doubt also is clarified by this example, sir. If there is a decimal point, you can ignore the decimal and then find the digital sum. 2 plus 3 digital sum is 5, whereas the digital sum of 2 is 2. Are they equal? No, they are not equal. That means digital sum cannot be used. Digital sum cannot be used when the values are approximated. Digital sum cannot be used when the values are approximated. That means I believe that you are able to understand when not to use the digital sum, right? You cannot use the digital sum directly if you are applying division, right? So digital sum cannot be used directly in division. Digital sum cannot be used when the values are approximated. Digital sum should not be used directly in square roots. Convert the square root into squares in answer options, which we already discussed. Like that, you need to know some of the disadvantages of digital sum also. Everything has advantages, everything has disadvantages, sir. Kindly comment in the live chat, sir. I want you people to comment so that we can take it forward for our questions. Yes, Ram Harish, that is exactly what I said sometime before. When you are dividing a number by 9, it is as equivalent to finding the digital sum of that number. You are asking me the same question, my answer is yes for you. Now, few important key points before we start the problems. Suppose for example 23570 into 10, or let me not take this 0, 2375 into 10. Now this you can directly easily write it as 23575, put one extra 0. Suppose if it is 579 into 100, directly you can write it as 579 followed by 2 zeros. These are all something which you know, but what I am trying to say here for you people is, saying you people here is, try to make this number as 10 or 100. I love having 10 rupees notes. I love having 100 rupees notes. I love having 1000 rupees note or multiples of 1000 rupees notes. Similarly, I love having 10,000 in my pocket. These all are very, very good numbers to work out with. I always want zeros at the end. I always want zeros at the end, because when I multiply those numbers, it will be very, very easy for me to understand, and then it will be very, very easy to solve that particular problem. Suppose for example I have 255 into, okay, I have something like 255 for example. I don't like this number called as 5 at the end. I don't like it. I will try to make it as 0 by doubling it. So it becomes 5 into 2, 10. So that my last number will become 0. These are all some of the shortcuts which we will implement in our class, sir. Right? Try to get these fancy numbers called as 10, 100, 1000, 10,000, etc. Suppose for example, I have 4.9 plus 5.2 plus 5.2 plus 4.9 plus 5.2 plus 7.9, right? 4.9 plus 5.2 plus 7.9. Instead of adding these three, have that nature of, what do you say, like distributing it to people. Please distribute some money to people so that they will also become so beautiful in their life. What I am trying to say you people is, I want to make these numbers as beautiful numbers. This number is having 0.2 extra, but this number is having 0.1 deficit. To make it as a beautiful number, take 0.1 from this person and give again 0.1 is there with this person, give that 0.1 to this person also. It is easier to add 5 plus 5 plus 8 rather than adding 4.9 plus 5.2 plus 7.9. That means have that beautiful nature of distributing things to people whenever there is a possibility. I don't say that when you distribute every number will look so beautiful like this in our problem examination questions or whatever it is, but at least try to make one or two numbers beautiful as much as possible. Try to turn around the life of people, sir. I am not saying that every person will turn around every other's life. As much as possible, try to turn around. That is what I am trying to say with this example also, right? Have that nature of distributions so that everyone will look so beautiful and it can be so simple. It can be so simple to start with. I hope the idea is clear. This one concept we will use it wherever possible. We will share the things so that other person will also be so beautiful. And the second thing is we will try to make these numbers as fancy numbers like this. Whenever I have 5, I will multiply by 2. Whenever I have 4, I will multiply by 5 so that it becomes 0 at the end. Like that it keeps continuing. These are all the methods which you need to implement in problem solving. Now you can also solve it in this method if you want to. Multiple methods are there, sir. Question is 5 into question mark is 8042 divided by 4. Instead of dividing 8042 by 4, this divided by 4 is nothing but in the denominator it is there as 4. I told you that whenever you have division, cross multiply and convert it to multiplication. It is 5 into 4 20. 20 digital sum is 2. 2 into question mark is 8042. So it is 2 into question mark is 8 plus 4 12, 12 plus 2 14, 14 digital sum is 5. What is the answer which we got? 402.1. 4 plus 2 6, 6 plus 1 7. 2 into 7 is equal to 5. Yes, 14 is equal to 5 because 14 digital sum is also 5.